Find the rate of change and slope from graphs, tables, and equations. So here we see rate of change and here we see slope. The reason why it's written like this is because that is how it was written in the book. However, rate of change is literally the definition of slope. So those two things mean the exact same thing. It's like saying mom and parent or dad and parent. Like, oh, one of my parents works here. I could say my mom works here. Or, you know what I mean? Like those two things are interchangeable. So don't let that confuse you. If you see rate of change on the test or if you see it written as slope, just know it means the exact same thing. So we're going to start off by finding our slope, also known as our rate of change, from a graph. Now, there's a couple of ways of doing this, and I'm going to pretty much show you all of them, so in case you run into a different looking problem, you know exactly what to do. To find the slope on a graph, we just need to remember rise over run. And there's not really a way to remember that. Just I guess you have to stand up before you can get out and run. So maybe that is the way. What does that even mean? We're going to count vertically before we start counting horizontally. Here we have a point, okay? And we always want to start off from a perfect point. What do I mean by that? I just mean don't start counting like right here or here where you have no idea what coordinates those are. Let's find some solid points. As you can see, I already have 2 marked on the coordinate plane for us. And let's start counting from there. We're going to rise up 1, rise 2, and then we're going to run horizontally. 1, 2, 3. So our slope is just 2 over 3. Pretty simple. Now let's say we are not fortunate enough to get a problem on our test that has a coordinate plane. Let's say it just looks like this and we are only given 2 points. What do we do? I'm not gonna lie, these are the straightest lines I have ever drawn on this sketch pad, so I'm really proud of that. And if you've been watching some of these videos, then you would know that. So there's a formula. Let's see what it is. It is simply y2 minus y1 over x2 minus x1. Holy cow, what do we even have to do here? Let's find what points we see here. This looks like a 1, 1, and then here we see 4, 3. Okay, now what do we do? y2 minus y1. Now you can pick either of these to be the first one or the second one. It does not really matter, and I'll show you what I mean by that. So let's say that we decided to make this our second set of coordinate points. We're going to do our y2. Here we have our x, here we have our y, and these are the second ones, x2, y2, x and y. y2, where is our second y? It's right here, it's 3. Minus y1, where is our first y? It's right here, it's a 1. Over x2 minus x1, where's our second x? Right over here is this 4 minus x1. Where's our first x? Right over here. And now we simply subtract. 3 minus 1 gives us 2. 4 minus 1 gives us 3. And whoa, it's like magic. We get the exact same slope. So that is that is pretty much the way to find it. I personally prefer counting because it feels like I don't really have to do any work, but it's up to you. And up to whatever the problem you're given looks like. So now that we know how to find the slope, also known as the rate of change, from a graph, let's see how we can find it from a table. Okay, let's draw some tables. X and Y. I'm going to make up numbers just to show you that it'll always work. 3, 4, 5, 2, 4, 6, 8, and 10. As you can tell, there is a direct relationship with all the numbers that I wrote. The x values increase by 1, and the y values are increasing by 2. What do we know from this? Well, not much, besides that it's a proportional relationship. So we need to find our slope. How do we do that? That is simply y over x. What exactly does that mean? We pick a y and we pick an x in the same row. That means we don't just pick a y over here. We don't just pick this y and then this x and think that we can just solve things that way. We pick any two that we want as long as they're in the same row. So let's go 2 and 1. 2 over 1 gives us 2. And then let's try the 6 and the 3. 6 over 3 also give us 2. All of them are going to give us 2. So that shows us that our slope is 2. Sometimes we're not given our tables like this. They're given to us like this. Now, don't let this intimidate you. It is simply just another way of looking at tables. Here's our x, here's our y. Let's say 1, 2, 3, 4, and 5 once again. And then let's count by threes this time. 3, 6, 9, 12, 15. What is the formula for slope from a table? Y over x. Pretty simple. 3 over 1 is 3. 6 over 2 is 3. 9 over 3 is 3. We get a 3. We get a 3. And so there's sometimes I see it taught differently, and in fact, I was taught it a little differently. So I'm going to show you how it is in case your teacher wants you to do it that way, which could be beneficial in the long run, but as of now, I don't really see when this method wouldn't really work, but who knows? I mean, maybe it doesn't in the long run, but I'm pretty sure it does because I have not run into a problem in which it has not worked. So I'm just going to show you this, mostly in case your teacher wants you to do it this way. We're going to pick two y's, let's say 9 and 6, okay? And then we're going to subtract them from each other. 9 minus 6. And then we're going to pick the same x's that we picked of the y's, 3 and 2, 3 minus 2, and we're going to see what we get. 9 minus 6, that gives us 3. 3 minus 2 will give us 1. And as we can see, that is just 3. It works both ways. Like I said, I feel like maybe the reason why they want us to learn it that way is because there might be some rare cases in which it doesn't work. But I've been doing it the way I showed you it for I don't even know how many years, and I have not seen an example for which it doesn't work. So this is just another alternative in case your teacher wants you to do it that way. But now you know two different ways. In case you forget one, you can try the other. The more you know, the better. And now from equations. So equations are a little, I don't want to say different, but fortunately in the curriculum it only says when they're written in y equals mx form. Very simple. You'll have to figure it out in a different way as you progress through math, but since we just have to focus on this one for now, then that is all we really need to worry about. Y equals mx. What do we do? M, believe it or not, that just means slope. Not sure why, it's just what letter they picked. And then we just plug in whatever we're given. Let's say y equals 2x, y equals 12x, whatever it is, this number right here is our slope. And then I'm sure in other videos I'll explain like what do we do if it's something written in another form, such as y minus y1 equals x minus x1. But for now, just remember that whatever you see in the m position when it is written in this form, that is going to be your x.